And let's change the view to speaker, which is me, which is my camera. Does that change your view to speaker, or you still can still do gallery? Like, do you see a whole lot of me, or do you have the option? Okay. Now what the heck was that? I had it right. Here we go. Okay. If I throw this in front of you, you're going, that's right. I know what it is because I watched the video coming into class. And I'm hoping you are 90% plus good with it, but you still might have some questions. But what we're talking about today are these things called linked list. Okay. It's a linked list. This guy is dynamic storage. It can grow or shrink if I want it to. The array was static, it wouldn't change size. So after today, when we go through the course, we're going to talk about a topic and then we're going to say, oh, let's look at it using array storage. Let's look at it using linked list storage. We've started and we're moving along in this course. And whenever we get a new data type, and this is like a great one as far as introducing a new data type, I start to think about what procedures are going to go with it. And if you watch the video, can you name some of those procedures? And I will wait. So you can unmute and we go, or we can sit here. But y'all need to get this cohort going.
Insert node was one of them.
There are chances I want to be able to insert. And when we got to insert, what would be good test data to take a look at? I'm going to create a new node, something that you did quite a few times and you're going to do a lot. New node is going to be a pointer. I'm creating that struct right away. It's going to point to null and it's going to have some sort of number in there. Again, we have a head pointer that points to a node. We're going to have new node that points to a node. So when I start thinking of insert and I look at a data type, this is really a generic one. What numbers might I have to consider with inserting? So when it comes to test data, no, you can't eat the sticky notes. We got 2 new kittens. So you can imagine how that's going. Give me test data. Come on. What'd you say?
One.
1? Keep going. Help me out, Austin.
Two.
This is 2. No, not 2. Why is 1 a good piece of test data?
It's before 4.
Right, it's going to go in the beginning. Well, if we're already doing 1, so when I get ready to write the code for insert, I want to make sure that all of these pieces of data, like if this was 1, would I be able to say, hey, head, before I go anywhere, new nodes next has to get the value of head. Sorry. New nodes next gets the value of head. Head gets the value of new node. So what are the steps involved inside of this procedure insert? Give me some more numbers.
5.
5. Keep going. Give me another number.
8.
Yeah. What do we
was
have to how do we deal with conflicts like that? Will there ever be a conflict? Okay, we're working with numbers. We could work with almost any type of data in here. One last number.
13.
18. Very good, Manu. It puts me outside on the end. Okay, give me another procedure.
Traverse.
Yeah, I'm going to need some kind of traverse. Traverse may happen where I am going through and just printing or displaying everything. I might be searching for something. So I go through looking at the list one at a time for a reason. Give me another procedure.
Empty.
Yeah, yeah, there's a lot of times we're going to want to check to see if it is empty. Now, with the array, I might have a count where I have to look at the count, excuse me, of how many items there are to see if it's empty. Here, how would I know if it's empty?
Eight head null.
Yeah, if head equals null or zero or false, or if somehow or other if head. Well, if it's fall or not, maybe I want to do this. If it's true, that'll help me to get in the loop, right? If there's something in there. So there's a bunch of different ways that were in that video that we talked about it. Insert, traverse is empty. Another big
Delete.
one. Delete.
Oh,
Yep.
I was gonna, or
I want
remove.
remove or delete. Yeah. So give me some numbers that I might want to remove. Test data. Looking at that list up there. Give me test data to delete.
7.
7. What else?
11.
11, which is out on the end. What else? What about 4? What if I delete it? What about 3? I go right to there and check. Oh, it's not. Yep, it's gone. What about 4? Deleting the first item. Deleting something in the middle. That's the 7. Deleting something that's not in the middle. Deleting the end. Deleting past the end. So I have a lot of different things that I really want to make sure my delete procedure function, it's called functions. Some languages call them procedures, just generic, but we should be using the word functions. And then there's going to be, depending on what we're talking about, there may be an append where I want to only add to the end something new coming in. So you watched those videos and you were all hopefully pretty good with what was going on. Now, let's pick a piece of something, either the insert or delete, and let's walk through insert or deleting because you've done it once in the videos. Now we're going to do it by hand, and then I'm going to get you doing some coding. So, pick one. Insert and delete are the best ones. What I'm going to do is empty because that's kind of already done here. Anybody? Bueller?
I say insert.
Insert. Okay. How about we insert the number 7.5? All right. 4, 7, 8, and 11. 4, 7, 8, and 11. Maybe we ought to make it 9 just to I'm drawing. Because if I said, hey, go ahead and write the code for that, how would you make out? Well, I told you about drawing the picture. Head. And I have I want to insert 9. So what's the first thing I'm going to need to do to insert 9?
Thought you said we were inserting 7.5.
Yeah, I changed my mind. What's the first thing we're going to
You need
do?
to find where it belongs.
Back up a little farther back. I'm going to call
need to-
insert.
Create a new structure.
Yeah,
create
create a
node.
new node. and you'll see over and over, there's camel case, there's new node. I take that structure and its data becomes 9 and its next points to null. Okay. Oh, this is a piece of cake. All right, what do we want to do next? Create the new node was perfect, right on. What's next?
We need to figure out where it goes.
Figure out where
Think.
it goes. But this, we're blind to this right now. We
Mhm.
really we could traverse it and display it and see it, but we're blind. We can't just say, "Hey, go right up in there," which is what we're gonna do, but not yet. I have to be able to move through my linked list. What do we need to move through a linked list?
A pointer?
Yeah, I'm gonna need some sort of and we may have a line of code that says temp pointer gets a value of
Head.
oh, very good. Again, these are my notes, but if I actually had to type this up later, it would be hopefully pretty good. So temp pointer goes to head. All right, now what am I going to do? Well, I'm going to use temp pointer to move through the list, which means later, right now, temp pointer is hanging out here. Agree? It's hanging out, storing that address. How do I move over to 7? How do I get temp pointer that points to this node to point to the next node? There it is. Austin had it. Temp pointer gets the value of temp pointer dash arrow next. That line of code now has temp pointer pointing at this node. Okay. I'm going to have to loop through. I might not know my loop yet. I'm going to have to loop through using this until it's found or until I reach the end. Give me some more thoughts we might need in here. Give me a while loop. What would end, what will end me from going through this list of 4,000 numbers?
If the node you're at is bigger than 9.
Okay, so we want to know if like maybe the insert was successful. So while insert not equal to true, while insert equals false, that means I didn't insert it yet. So I can lots of ways to do this. But I need a way to say, hey, either I was able to insert it. What's my other option? Do I have another option? It's going to get inserted somewhere, right? Where would be the last? If I had 24, it would be inserted out here at the end.
You would
So
append it.
yeah, yep. So, but when I append it, I'm still going to be inserting it, right? So
Mm.
I may just let this go, and then inside of here, once insert equals true, because it's going to go somewhere. With me so far? Okay. All right. So right now, let's see, temp pointer equals head. Maybe I needed to put something else in here yet. Maybe I should have used pencil. Before I get in that loop, what number might be inserted? Three? Three? So, oh boy. So maybe I shouldn't have put this in there yet. Let's slow it down. I can always come back to it. I didn't totally blot it out. If new node value is if new node's value is what? This guy.
Less than.
Yep. Less than head value. If that's true, that means I would be inserting right there. Ah, okay. So how would I insert right in the front? Give me some lines of code. I'm going to find out if you know what we're doing or not. What would I like to happen? I'd like, if this was a 3, I need this to go and point to here, and I need this to go and point to my first thing. If this was a 3, I want this to come to here, and this to go up to there. I don't even need temp pointer yet. Head equals new node. So if head equals new node, what does new node equal? Does new node's pointer go to? We don't know because we lost our whole linked list. Something should be done before that.
Make a new node.
No?
Oh.
We're all close. I need something along the lines of new node next gets the address of, because this is holds an address, gets the address of head. We need this to be done first so we don't lose our list. Now that second line, head gets the value of new node, gets the address of new node. Ah, what did I just do? I just did insert in the beginning. I just did insert in the beginning. I may even need to throw something in here that says we were able to insert it. Insert equals true. Because remember, the next thing we were going to do is get into that while loop, meaning we didn't find it yet. And then I'd have to move through one big line of code. Remember here, move through. We were going to use that. We had this line of code, which was my loop. While insert equals false, that means it wasn't the first item, and now we're ready to move through. And generically, I'd be saying if, okay, so temp pointer is here now. If that value was larger, then I'd have to insert. Then I would have to insert. So inside of that loop, I'd have an if statement. Okay, the last thing I want to do. All right, we have 8. We had 11. This actually pointed to null. And we just moved through and new node, excuse me, temp pointer goes here. New node points here. This is a lot the first time, by the way. But we're going to learn something. We're going to look at it as an array. We're going to look at it as a linked list. Then we're going to learn something and we're going to look at it as an array. Then we're going to look at it as a linked list. So you're going to end up getting pretty darn good at this. So right now I'm here and I'm going to say, part of that if statement looks like. So we know it didn't go there. I want to find out if it goes here. We made a statement that said something with an if statement. So if, what am I checking for? I'm checking to see if this goes in here. The only way this goes in there is if it's less than. So hit me with your best shot. Oh, yeah, now you know why this isn't a total online course. All right. If, here we go. Temp, pointers, next, oh boy, value. What is temp pointers next value? It's 11. If that is greater than new node's value, then I want to insert it. So my temp pointers next, which is the address of this node, and at that address, the value, which is 11, is greater than new node's value, which is 9. I want to insert it. All right. Come on. Tell me what to write. Tell me what to write. Tell me what to write. How many of you think you could be sitting in a computer and doing all this without writing it down and drawing the picture? All right. So let's see. What I need to happen is this guy, going to just make it light, needs to go there. This guy needs to go there. But I have to ensure integrity. I don't want to lose something in my linked list. Order does matter. We saw that a little bit earlier. So what should get done first? This line or this line? How about I ask you to guess? The first one or the second one?
The second one.
That's
The second one should be done first. Okay. And
No, the other one.
this one?
Yeah.
Okay. So if this is done first, that means this guy just went away. Oh,
it was the first one that you pointed at. The
Yeah.
the second line, which was the first line that you pointed at.
we want to do this one first.
Work backwards.
Yeah. Because if I would go from here to here, I just lost the address of the rest of my stuff. So this one's got to be first. And this one is going to be what line of code? I want to know who's got it. You pull this line of code off, you got it. I want to make this connection.
Is it temp pointer next equals new node?
Temp pointers, well, that would do this line first. Temp pointers next, we get the value. So that's actually going to be our second line. Temp pointers next. Temp pointers next gets the value of new node. That would ensure this line. But if I did that first, I just lost this. So
New
we're-
node gets, new nodes next.
new node next. How about I go new node? Now I put next, gets the value of, again, this is an address. This gets the value of, where is this address? New nodes next gets the value of, really close, Manu. It gets the value of temp pointers. I want to, what points to this? I want this to point to this node. What points to this node? And that's this line right here. That line is temp pointers next. Yeah. I don't know why I put it. What the heck did I just do? Did I put them in the wrong order again? Screw it back up.
You put them backwards.
I did.
I
Yeah.
said that, and then I watched you write it underneath, and I just figured I wasn't understanding something.
Okay. So I'm going to go through it slow so we're not screwed up. First one was this: new nodes next. That's this line right here. What address is it going to get? It's going to get the address of temp pointers next. New node, which is right here, this gets that address. Okay. Now, temp pointer, which we did write a minute ago, temp pointers next is going to get the value of new node, the address, right? And that's just new node. Okay. I can't believe I switched them up. That's pretty sloppy, buddy. Yeah, I know. Yeah. This is really new stuff. Boom, 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 to be able to keep moving through there. What you think? So some of this stuff, and we're going to talk a little bit more about in the future, is what if I have a linked list? What are you doing? Let's go clean. What if I have a linked list? Now that we're familiar with them, and it looks like this. Are you telling me there's more options? Yes. So there's a linked list. Kind of nice and simple. We could have pointers all over the place. We had a temp pointer that pointed to the front. We have lots of different things. Well, we're gonna have a section where we're gonna talk about a circularly linked list. That would be one. Circular would be one where instead of pointing to null, it's going to point to the same place head points to. Thinking outside the box here. Different things that are going to go on. We're going to look at, spend a whole day on this one. And what do I mean by this one? It's going to have 2 pointers. It's going to be called a doubly linked list, where I have a pointer to the next memory address that I want to store. I could have a pointer that takes me back one. So in each node, I'd have 2 pointers. This is called a doubly linked list. What you think? You want to start trying something yourself? So in the video, I went through, oh, there goes a comb. I went through all of this, we're going to start out with a struct. It's going to have a value and a pointer to a pointer called next that points to a list node. What's a list node? That's this guy. We're going to have head. We're going to have one called head that is a pointer to a list node. That's how I get all of that started. Hopefully a lot of this sounds somewhat familiar. We just did some appending. We were jumping around. Hopefully makes a little more sense than just watching the video. Book does a really good job of a lot of this. You eventually get into list.h and list.cpp. And they were given to you in a folder. So you would now have these things to work. This is just a demo of using it. This demo is using the append node function that appends to the end. And somebody said that's an option. Here's a way to display the list. So that means there's a specification file called numberlist.h and an implementation file called numberlist.cpp, excuse me. So those guys exist. And then the book talks about inserting, and so did we. We talked about deleting, but you notice that one topic after another, we have pointers and node pointer and previous node and so many different things going on. So I'm going to put you in, we have 11, so I'm going to go with two groups. First things first, I want to go and, where are we? We're here. There it is. Share this. And this should be the chapter 18 that I gave you. Yes. Yes. There's number list. And as I mentioned earlier, the header file and the implementation file. Should we open them up? Y'all have to get a little more. Yeah. All right. Can you see my IDE?
No.
No.
No,
Stop
we can
sharing.
we can see your file explorer though, or we could. Now we can see the book.
Can you see it now?
Yep.
Thank
Yes.
you. All right. So we have numberlist.h. Here's append. It's already put in there for you. Some of that hopefully looks a little more familiar, like line 23. If not head. Checking to see if it's empty or not. There's the next. Here's display. That's just going to go through one at a time, printing them out. It's a good one to walk through to start because until I get to the end, while node pointer. That's that whole true and false. Null is false. Okay. So if this node pointer was pointing at null, it would get out of the loop. If it's not pointing to node, it's going to be true. Excuse me, if it's not pointing to null, it's going to be true. I print out a value and I move to the next one. Insert. Yeah, we knew that was going to be a boatload of code. Because we have to insert in the beginning, which is lines 81 to 84. And I'm sure there's inserting, moving, getting to the end. Else, otherwise insert after the previous node, getting me down to the end. Delete is the other big one. But again, if you do all the thinking up front, I'm looking inside of delete and I see most of that's actually documentation. It's not big lines of code. Nope. Questions? Questions at all? All right, so what do I want you to do today? Well, number 2, list print. That is, oh, look, we kind of already saw that. There was a function done to display. So since we took a look at that, we're not going to do that one. But we're going to look at list reverse. Modify the linked list class that I just gave you, adding a function named reverse. Reverse rearranges the nodes in the list so their order is reversed. Now you can go and add it to stuff that I already gave you that's available. You can go and take what I gave you and just take a bunch of other stuff out to make it clean. But I want you to reverse the elements in the linked list. So you display the linked list once, great. You go and reverse it, and then you go and display it again. So it sounds to me like you're going to add 5 numbers, print it, reverse it, print it. Is there going to be one way to do this? Nah. There's going to be a couple different ways. You are to achieve this result. So when I go to head, the first time it may be 4, 6, 12, but after I reverse it, when I go to head, it should be 12, 6, 4. However many numbers there are in there.
Sorry.
We good? No questions?